Let's look at the second method to deal with arrays and function calls. Again, take a same array. So for simplicity, let's say int list of 5 equals some random 5 elements 10, 25, 12 and 2. My function is going to look a little bit different now. Void display int k brackets comma int size. And the way I'm going to call this function is I'm just going to say display list comma 5. So what I'm doing is I'm sending the whole array and I'm also sending its size. So the size here is 5. And that's the end of my program or the main function. Now let me write the display function. Void display int k brackets comma int size. So basically size is 5 and here k is another array which is a copy of the list. So essentially you are making another array. Then I can have int I for I equals to 0, I less than or equals to size minus 1, I plus plus, printf percentile d comma k of I. That's the end of my display function. So compared to the previous program, here we are only calling the display function once. However, the drawback is that we are making an entire new array or a copy of it. In fact, now you have two arrays. This program is not a problem for arrays of fewer elements. So in this case, we have only 5 elements. So essentially, when we make two arrays, we are going to have 10 elements. Now imagine if the original array is, let's say, 500 MB of data. Now here, when you create a new array, you are making another 500 MB of additional data. So that's about 1 GB in total. So you are doubling the memory usage. Now this is very bad in embedded programming or in embedded systems because memory resources are very less in embedded systems, and embedded systems are also supposed to be fast. So using method 2 in embedded systems, there's a lot of memory usage, and in method 1 the time consumed is very high. So both these methods are not suitable, especially for applications which require a lot of speed. So how do we deal with these two problems?